Welcome to our tool management room here at HAIMER in our soft machining production. Here we're changing around more than 200 tools for our around 120 CNC machines in this area. And since many years, we have a central process where one colleague in the tool management room is changing centrally all the tools for our production machines. So this gives us more control for the clamping, presetting, and balancing of the tools, and is dramatically reducing the crashes in the machines. And the machine tool operators, they are allowed to change the sister tools out of their machine tool magazines by their own. So if there is an old and blunt tool in their machine tool magazine, they bring it to tool holder cards like this here. So you see here, that's a tool holder card for the NHX machines. And if they have a blunt tool, they bring it here, place it on the right side, and I can see visually if the cutting tool has no label, then it's an old tool. And here on the left side, I can see tools with a label. So these are new tools, and the machine operators are allowed to take these tools, bring it back to the machine tool, put it into the magazine, and go on producing. And when there are several blunt tools here on the tool holder card, then our colleague from the tool management room, he can take several pieces out of the card, bring it to his assembly station, and starts changing the tools. And this is what we're going to do now. And we take these two tools, for example, and let's go to the assembly station. So that is the physical process that we have since many years, and since last year. And now we are using a tool management software, which is called WinTool, to also copy the same process in our digital world. And to copy it, I also need to transfer these tuples, these sister tools, from my tool holder card to the assembly station. Therefore, you already see on the big screen, we have the WinTool app already running, and in a special module here, we are transferring and put the tuples to different locations. And to identify the location, the assembly island also have a unique ID code, and when I scan it here, then the assembly island number 2 is identified. And the next step is, WinTool is asking me, what is the tuplo you want to transfer to this location? Therefore, I'm scanning the unique QR code, which is here on the label of my tool holder. So therefore, just scan the QR code, first piece on this setup, on this assembly station, second end mill on the assembly station. And now my colleague in the background, he will create out of both tools that are on the assembly station a so-called setup list. And we're gonna create this setup list. So we're gonna now take a look at the setup list. This is like the manual for our colleague, how to change the tool and which components he needs. And you can see here, that's my ball nose end mill. You see there's a 2D drawing, all the gauges, the stick out lengths, so all the gauges he needs to know, and also basic information about the complete tool assembly and information about the components that are inside the tool assembly. That means we have here the coolant tube, the holder itself, and the cutting tool. And also these components have identification numbers that are written here and also printed out as a data matrix code. And that's a simple report, a PDF report. I can open it on a tablet, on a cell phone, on every PC. I can even print it out, but in this case we work paperless. And in the next step, we want to get a new tool. And to get a new tool, we need to get it out of our big storage system, the handle lift. And to get it out there, we are using a second software. So now we are switching the software and take a look at Toolbase. because Toolbase is our go-to software to do easy withdrawal and filling of storage systems. And you see here, we are in a login screen, and what my colleague is now doing, he will log in with his ID card. So all the bookings that he will do now are stored in the history, and we can also do some analysis afterwards. Now what we want to do withdrawal of an item. So we're choosing first item, and then we are saying we want to show all items. And then we have over 10,000 different items here, and to find the correct one, we are simply using the data matrix code of the identification number of the end wheel, which has been shown on the setup list. So when he now scans this QR code, we're finding the exact right information of our ball nose end wheel. And you can see here, now we are open this information about the end wheel. Here on the left side, you can see picture, drawing, basic information. And this is centrally coming from WinTool. So no double handling of database. We set it once in WinTool and then send it to Toolbase. And what we now are going to do, we want to have quantity, one piece. And this one piece we are putting into our shopping basket. So we do like online shopping. Everything we need, everything we want, we put into the shopping basket. Now we want the second end wheel, therefore same procedure like before. All items, we are scanning the identification number, finding the right end wheel. We have the information, quantity 1, into our shopping basket. And now shopping basket is filled. Now we want to have everything withdrawal, and therefore we say start withdrawal. And now Toolbase is sending a command to our big panel systems. They start moving, and this is where we go to now. And you see very quick, very fast, with getting us the right table, and with pick by light, so with the red light, it's showing the operator exactly where to pick the first end wheel. And then he's confirming the pick on a second screen here in the center, so with very short ways. And Toolbase is jumping automatically to the second item in our shopping list. And you see on the right side, the next lift is moving, bringing us the second table. And again, with pick by light, it guides the operator to the exact position, picking the right end. Now, as he's confirming the pick, we are finished with this shopping list, and we are logging out of the software. And now when we log off, then you see the tables, they will drive back into the storage system, because we don't want any other operator to make a wrong pick, so that the stock information is always perfect inside here. And that's essential for HAIMER, because Toolbase can also be connected to the ERP system. And when for some items we are running beneath a certain stock level, Toolbase will automatically generate the order that has been sent to our ERP system, and then our purchase department directly sends this purchase order to our suppliers, so that we never run out of stock and can go on producing. But now we're done with all the scanning. Now the real tool changing will start, and therefore we are using our PowerClamp Premium i4.0 shrinking machine. And as there is this constant cycle of changing tools, we are in this case taking the height of the old end mill. Now my colleague is also scanning the QR code. Then this QR code is setting up the machine. You see the motorized coil moving automatically to the correct diameter. The parameters for heating are already predefined in the control. And the next thing my colleague needs to do is move down, pushing the button of the induction coil. Within few seconds, we are heating up the holder. The bore opens. We can take out the old tool, put in the new one, and then going back to the height gauge. And then you already see here the green flashing light on the cooling body, telling the operator where is the position to cool down the holder. And when he moves down, you see it switching to red, because there's a temperature sensor inside measuring the temperature of the holder, signalizing, hey, this is hot, you should not touch it, therefore it's now showing us with a red light, we need to cool down, please wait until it has a safe temperature. Now, as this is a station with many cooling positions, we can of course do simultaneous work. Therefore, my colleague now goes on changing the second end mill, and it's the same procedure like before, scanning, moving down, pushing the button. And you see also, no matter which operator is using the machine, it's a push button system, always same quality in clamping, same quality in run out, not like with a collet shock where you're over tightening, under tightening. It's always same quality, very fast, very clean. And you see here again, cooling body is flashing, telling us, hey, that's the station where you need to cool down. And there is constant water circulating in the cooling body. Down in the base unit of the machine, there is like a refrigerator bringing the cooling liquid always to the same temperature. And therefore it's very fast, very efficient in cooling. And you already see now here, it's red flashing, telling us now we're beneath a certain temperature level, it's safe to touch, and therefore I can move up the cooling body, I can touch the holder, it's safe to touch, and therefore we can go on with the next procedure and changing the tool. And that means we're going to the balancing and the presetting machine. And for balancing and presetting, we are using our unique TD preset, which is a combination of balancing and presetting machine all at once. And also here in the database, we already have the information of balance grade, the rotation speed, the weight of the holder. So my colleague now is clamping the holder, starting the first measuring cycle. We are accelerating to 1,100 RPM. We make certain measurements. There's a forced measuring sensor at the spindle, really measuring the forces coming from the unbalance. And now he's doing the so-called index measuring. That means he's turning the holder 180 degrees, clamp again, and starts a second measuring cycle. And both results of these two measuring cycles, they are calculated together, and therefore we can compensate the influences coming from the spindle and the adapter. So the final balance result is only holder and cutting tool. And we see very quick and easy, it's green, that means we are in tolerance 1.0 gram millimeter. We are allowed to go 18,000 RPM, and then we have a balance grade of G1.3. That's better than G2.5, which is the balance grade that is requested from the machine tool spinners. Now as the balancing is done, we are going on with the presetting, and therefore moving with the optic carrier into the measuring area. My colleague is cleaning the cutting edge, and what we're going to do now is we want to measure a toolkit. But there is still an old toolkit in this list, and we need to update this tool list now, and this we simply do by using the WinTool interface. Because we already created in WinTool a setup list. This setup list is available now, and when I update the list, you can check here the list and the picture is changing. So we are taking again the predefined data from WinTool. When I double click here, I also have again the 2D drawing, which is sent via WinTool. And when I start the measurement, there is also already predefined what is the nominal Z length and what is the tolerance, in this case, plus minus 0.05 of a millimeter. And now my colleague can start doing the measurement. In this case, he's applying the Z length, confirming it, and then we are printing out the label, because we are always want to have the label around the cutting tool signalizing it's a brand new tool. And we are also writing the information on an RFID chip. That means X, Z values, and also the information about the tool life, so that we have always decentrally stored all the information on our tool. And now I make this tool again available for our production, and therefore we go back to the tool holder cart. And also on our machine tools, we have RFID reading units directly in the machine tool magazine. So when our colleagues are placing the tool into their tool magazine, they don't need to do any manual typing of X or Z values because it's directly coming from the RFID chip. So no typos can happen, no mistakes, and you have higher process reliability in our machine. So in the last step, I want to place the tool holder here in our tool holder cart. And of course, I also need to copy the whole process in our digital world in WinTool. And therefore, again, I have the tool holder cart NHX. For the NHX machines, I have a unique QR code to identify this location. I scan this, and also I have the unique identification number on my tool holder. I scan also this, and then I place the tool here on the cart. So now all the operators know it's a new tool. They can take it out, use it in their machine, and also all the users of WinTool in the company know if they're looking for a ball-nose end mill diameter 14, they can search in WinTool. They know, do we have a new tool and where is the new tool? So it's less searching and shorter times when it comes to set up a new job. So now the last tool is also finished. My colleague hands it over. I'm again scanning the tool, place it here. So also the straight end mill diameter 20 is now on this location. And now the complete process of changing the tool physically and digitally is finished, and my colleagues can go on producing. To organize all our tool assemblies and also to do the scanning of our sister tools, we first of all need to create a digital twin in WinTool. And how fast and how easy it is to create a digital twin within just 1 minute, I want to show you now on our Microset Biolinea with 2 screens, and here we also have WinTool on the right screen. And I want to create a digital twin out of this tool here. So this is a HAIMER mill power series 5-flute end mill clamped in a HAIMER power shrink chuck ultra short, and we are using this tool on our NHX 4000 machines for machining and finishing a part which we then use on our tool balance. And I'm now using here WinTool to create a tool assembly. Therefore, I have the tool assembly section, and I say I want to create a new data set. And then I need to connect the new data set with the machine. In this case, we take the group of NHX 4000 machines. And then WinTool is asking me which is the first component I want to start with. In this case, I go to my library, and in this library I have 10,000 different parts. It's cutting tools, tool holders, spare parts, and other usables that we have in the whole production area here. And to find the right component out of the 10,000 pieces, I just use a QR code which is on our packages. So I just scan the code, and so WinTool finds the exact right component, and I choose this end mill. And now you already see that we already have a 2D drawing of the cutting tools. And WinTool always places the tool like this. That means here's the cutting tool, and now on the left side we are missing the tool holder. So I say to WinTool, please add a component on the left side, and please find a matching component. And the matching component means that WinTool has the intelligence to know this is a straight shank, 20 millimeters in diameter, so please, WinTool, only show me the tool holders that can clamp 20 millimeters in diameter. And I have now only 3 results. That's a collet chuck, a standard shrink fit chuck, and the power shrink fit chuck. And I say, please take the power shrink chuck. And now WinTool adds the tool holder exactly on the right position in combination with the cutting tool. And so I already finished the tool assembly here. and I have a 2D drawing, but I also have a 3D model. And here you can see different colors on the 3D model. And you see here the yellow section, that's the cutting fluids on the cutting tool. Blue area is the shank of the cutting tool, which is the no-cut section. And gray is the holder, which is also the no-cut section of the tool assembly. And this is essential information because we can now send also the digital twin to our CAM system, and we have all the information about cut and no-cut section available, because in the CAM system we want to do the collision analysis, so this information is therefore very essential. And so you see, instead of taking 15 minutes drawing a digital twin in my CAM system, it just took me 1 minute in WinTool, and now I can spread via different interfaces all the information to my other different systems like CAM or like our presetter.